Hi everybody, happy Tuesday. Today we're going to be talking about a new periodic trend, and that is atomic radius. So what I want you to do for today is, all I want you to do is take some notes on these videos and what's on Schoology and write down the examples, and then all I want you to do is to upload them. So if you're writing them in your notebook, you can take a picture and upload them. If you are doing it on Google Docs or a Word doc, you can attach that document, or you can just copy and paste your notes from Google Doc and Word doc into the assignment itself. And so our first order of business is to define atomic radius. And so this is the definition. It says atomic radius is the distance from the center of the nucleus to the very outer ring. So what that is right here is our nucleus. It is this distance. I'm going to label that as R. Before we get too deep into discussing atomic radius, I want to talk about something fun, which is concerts. And concerts are one of my favorite things to do. And I don't know about you, but when I go to a concert, I want to be as close to the stage as possible because I really want to get a good view of the musician. And so sometimes, however, there are barriers in the way. And you can kind of see it in this picture. There's like a barrier keeping you from the stage, and then that kind of keeps you farther away from the stage. And sometimes if it's like a really big venue or it's going to be really crowded, they put multiple barriers in to separate large groups of people. And so then you kind of end up being farther back from the stage. So when we're looking at an atom, because I know you're all thinking, how does this relate to what we're doing? Our energy levels, or rings around our nucleus, are like these barriers. The more you have on, the farther some electrons are going to be from the nucleus. Just like when there's barriers at our concert, we kind of end up being a little farther away from our musician that we came to see. However, sometimes if you get real lucky, there might not be barriers at all. And so when I go to a concert without barriers, and you can get right up to the stage, I usually try to find my way close to the front and pick my spot, and that's where I usually stay until more people start coming. And so when more people start coming, and they like to get in front of you, I usually end up moving a lot closer to the stage because I don't want people in front of me, and I want to be as close to the stage as possible. And also, as people pile in, you naturally get pushed to the front of the stage. And so our atom is kind of the same way. When we keep adding on electrons in an energy level, so in my second energy level, as I keep adding on electrons, it gets closer and closer to the nucleus because there's an attraction between the electrons on the outside and the positive protons in the center. It's kind of like a magnet. So the more you add electrons onto an energy level, the closer it gets to the center because there's more of an attraction. And so what does this have to do with atomic radius? Well, both of these things, adding on energy levels and adding on electrons, changes the size of the atom. And so when we add on energy levels and rings, it gets bigger. And as we add electrons, we saw it got smaller. And I just want to make it super clear, even though when we are adding more energy levels, we are adding more electrons. But because we're adding energy levels, it makes it bigger. When you are adding electrons in the same energy level, so I just drew 2 right here, if I add on 2 more, the distance is actually going to become smaller because I have more on the same energy level and it's being attracted. So we're not adding another ring, we're just adding more attraction.